Today, we're diving into Dynamo. And look, if the word code immediately makes you think of some super complex, inaccessible programming, let's just park that idea for a second. We're going to explore Dynamo not as some kind of barrier, but as a really powerful new language for thinking about design and then, actually bringing it to life. So think about it this way. Instead of manually clicking and dragging every single point, every line, every surface of your model, what if you could just write the rules for it? What if you could design the logic behind the form and then just let the computer handle the thousands of clicks it would normally take to build? That's the big idea we're digging into today. And hey, this isn't just me trying to reframe it. The creators of Dynamo themselves said they built its language specifically to express design intentions. That's the absolute key here. This is a language built from the ground up for designers, made to translate your creative goals into a logical, really powerful script. Now, the formal term for all this is computational designing, but I really want you to focus on that one word, exploratory. This isn't just about making the computer work faster for you. It's about creating a system of rules that lets you explore hundreds, even thousands of design variations and complexities at a speed that would be just, well, impossible to do by hand. Okay, so how do we get started? Well, we start with the absolute simplest element you can think of, a point. Seriously. Just like a massive tree grows from one tiny seed, every piece of complex geometry we can dream up begins with just defining a single location in space. To create our very first point, we need to write a little recipe. It starts with 3 simple ingredients. First up, we create a variable called x, and we're going to give it a value of 10. Next, we define y and give it a value of 2.5. And finally, we'll set z to -6. Now, we haven't actually drawn a single thing yet, but what we have done is written a crystal clear 3-line set of instructions for a very precise location in 3D space. And this is the action. The command point by coordinates is what's called a constructor. Just think of it like hitting the go button. It takes our 3 ingredients, x, y, and z, and it executes the instruction to actually create the point. And just like that, we've stored our brand new piece of geometry in the variable we've called p. Okay, great, we got a point. That's our fundamental building block. So now let's see how this thing scales. We can start connecting these points to create lines, and then we can connect those lines to create surfaces. This is where the complexity really starts to ramp up. This lays out the logical hierarchy perfectly, right? We start with points, we use a command to connect them into lines, then we use another command to basically stretch a surface between those lines, kind of like a skin. Every single step is an action that builds directly on the one that came before it. All right, so creating one point is simple enough, but what happens when you need 100 or 1,000? This right here is where computational design really starts to blow your mind. We can use super simple rules to generate massive complexity and just let the computer do all the tedious, repetitive work for us. And this slide just says it all, doesn't it? On the left, that's the old way, manually typing out every single point. It's boring, it's tedious, and you're bound to make a mistake. But then you look to the right. That's the Dynamo way. A single, clean, elegant line of code does the work of all of that and more. This is that big aha moment. So how in the world does that work? Well, that little expression 0.10 is called a range. So instead of giving the x-coordinate just a single number, we're giving it an entire sequence of numbers, from 0 all the way to 10. Dynamo instantly gets it and creates all 11 points for us, perfectly spaced out in a line. That is the power of automating repetition. But what if you want a grid, not just a line? Well, this is where it gets truly powerful. By adding these little tags, these things called replication guides, we're actually changing the matching rules. Think of it like this. Instead of pairing the first x value with the first y value, we're telling Dynamo to pair the first x with every single y. Then take the second x and do it all over again. Pair it with every single y. With that tiny little change, a single line of points just explodes into a full 2-dimensional grid. That's exponential power right there. So we've made points, we've made lines, and we've learned how to repeat them to create entire grids. Now let's combine all of these building blocks into a single, much more sophisticated design script. First, we take a whole collection of our points and we feed them into a nerves curve command. Now, don't worry about the name. You can just think of a nerves curve as a really smart, flexible wire. It takes all of our separate points and calculates the smoothest possible curve that can pass through them. This smooth line is going to be our base geometry. Okay, now let's take that flat curve and give it a third dimension. The surface.revolve command does exactly what it sounds like. It takes our curve, it takes an axis to spin around and an angle, and it just revolves it 360 degrees to generate this beautiful, complex 3D surface, kind of like a vase on a potter's wheel. Now, this line looks a little complicated, I know, but the idea behind it is actually pretty intuitive. Think of our curved surface, like a globe. A globe has lines of latitude and longitude that create a perfect grid on its surface, right? Well, this command does the exact same thing. It creates a grid of reference points that are mapped perfectly onto our 3D shape, giving us all new places to build from. And for the final step, we run a command on every single point in that new grid we just made. For each one, it draws a short little line sticking straight out from the surface. And the result is this dynamic, textured pattern, a level of detail that would be incredibly time-consuming, if not impossible, to model by hand. So, in just a few steps, we've gone from defining a single invisible point in space all the way to generating a complex textured 3D form. We've seen how a few simple rules can build on each other to create some truly stunning complexity. This is a fundamental shift, moving away from the manual labor of clicks and toward the creative act of thinking in systems. So the real question isn't just about automation, it's about imagination. If you could write the rules for any design, what would you create?